Hi, my name is Miroslav Oljača and I'm Senior Application Manager for Analog Products from SMSC. Today we are going to talk about ESD protection and layout techniques associated with UCS products. ESD problem is a well-known problem that need to be addressed specifically in consumer applications. For that reason, all electronic devices will have inherited ESD protection diodes internally to that circuits. As we can see on the diagram number 1, internally of UCS100 series there are ESD diodes from output and input pin as well as a V-bus pin to the power supply and the ground. These ESD structures are going to protect any discharge that can occur on these I/O pins and protect device from damaging. If we would like to increase robustness of our devices, we will need to put some kind of impedance between ESD discharge source and internal ESD diodes of the part. As we can see on this slide, we are adding common mode choke between output pins of UCS and USB connector. This choke has primary function of limiting EMI radiation that can occur during the transmission of the signal, and as a secondary function it will add impedance between ESD discharge source and internal ESD diodes. So the voltage that we can apply on the pins of the connector can be higher than in the previous case when we were operating without common mode choke. In many applications, adding the common mode choke or some additional impedance between the connector and the device is not good enough. For that reason, we are going to apply additional protection on these pins. On this slide, we can see that not only common mode choke is added between output pins and the connector, but also additional ESD discharge diodes are added between connector pins and a ground or a shield of the connector. This will take care of any ESD problems that can occur on the signal lines, but in the case of the ESD problems that are occurring on the power supply lines, which can be ground or plus 5 volts, we need to treat signal differently. On this slide we can see that in the case of ESD discharge on the power supply pin plus 5 volt on the connector, some of the discharge will be discharged through the capacitor that is close to the part on the V-bus, and some portion of that will be discharged to the ESD diodes to VDD pin on the power supply of UCS100. In many occasions, this will be more than enough to protect our device from additional discharge. But if we want to be bulletproof, then some additional tricks can be used. On this schematic, we can see that variable resistors are added on the power supply and the ground, signal ground, going to the shield point of the connector. Now, in the case of ESD discharge on a plus 5 volt, some energy will be, or better, majority of the energy will be discharged to the variable resistor. Remaining energy will be shared now between capacitor on V-bus and internal ESD diode. This solution will show us very good results in the lab and on the field, but in some cases for very difficult environment we need to go a step further. Here we can see that the shielding ground or ground of the connector and signal ground are only DC coupled through the big resistor and maybe some capacitors in parallel. Once when that is applied, then additional inductance is needed between variable resistors and input V-bus or ground pin on the UCS100. From this solution we can see that it's adding additional components in front of the UCS or between connector and UCS part. We can have protections from required 8 kilovolts up to the 30 kilovolts discharge on a positive or negative or any pin that we want to do. We saw schematics for different levels of protection of UCS parts. Next step will be to apply that for the PCB board. From this slide we can see optimized layout where D positive and D negative pin on USB port are connected directly to the shielding ground through discharge devices or ESD diodes, and also VCC and V ground, power supply plus 5 volt, and the ground, signal ground, are connected through the variable resistors to the same point of the shielding ground on USB connector. Now we are in the lab, and everything that we saw before on our schematics we are going to apply on this board that we have. We put all protections that are possible on DPD, M pin, as well as on the power supply pins, plus 5 volt and the ground. Bill, can you show us how you are going to do the ESD testing?
Sure. I'm Bill Burdett, SMSC Applications Engineer supporting the UCS1001 and 1002. We've been doing quite a bit of ESD development here using this fixture. Rather than just discharge to an open connector, I have a setup here where I can isolate each pin of the USB and perform a direct air discharge to the pin under test. What I'm going to set up here is the DP pin, will be the pin under test, and then we will use our ESD equipment to air discharge directly to the pin. We now have it grounded. We have our ESD table ready. We have the pin under test exposed. All other pins are covered by the plastic header, and then we will begin the ESD test. Okay, I've adjusted the ESD equipment to plus 30 kV. Now we will take the fixture over to the USB high-speed eye diagram test system and verify that no damage was sustained to the fixture. After the ESD test, we want to verify that the high-speed switch has sustained no damage. What I'm going to use here is the Agilent USB 2.0 automated system, which will perform an eye diagram measurement to ensure that no damage to the high-speed switch or the fixture itself was sustained during the ESD testing. I have our ESD fixture circuit board, the Agilent breakout fixture, the Infinium scope, the high-speed test tool which will run the eye pattern, and then an automated panel that will make the measurements and give me a pass-fail result. The USB has been enumerated, so I will begin the test. So as you can see on the scope, it's running a test pattern and making an eye diagram measurement. And the test is complete. The results are all pass for this circuit board, so we know that the high-speed switch and the entire board sustained no damage during our ESD test.
For more information, visit smsc.com.